Section 3.2a is about solving using addition. Solving what? Solving equations. Well, let's talk about what solving an equation is. It's finding all the values of a variable that make the equation true. Here's an example. X minus 3 equals, let's say 5. So if you look at that equation, you should be to the point in your life when you can probably look at this and say, what number, when I subtract 3 from it, will give me a 5? Well, the answer is 8. So the solution for this equation, or if I were to solve this equation, I would say that x equaling 8 is my solution, because if I put an 8 in for x, it makes this equation true. There's no other number in the world. There's nothing else in the world that I can put in for x that when I subtract 3 from it will give me a 5. That's solving an equation, finding that number. Now, this one's very easy. We have to give you a procedure for how to solve equations when you don't have ones that you can do quickly in your head, and that's what we're going to do in this section. To solve equations, we're going to use a very official sounding property called the addition property of equality. And what the addition property of equality says, and you can read it here for yourself, you can even look at how the symbols go, but in general, here's what it means. It means you can add a number to both sides of an equation. And as long as you do it to both the left and the right side, the equation stays balanced. And those equations are still equivalent. The equivalent equation means it's an equation that has the same solution. You can do that by adding positive numbers. You can also add negative numbers to both sides of an equation, and the equation will stay equal. That's called the addition property of equality. We're going to use that property to solve equations where we don't know the solution to. So I'm just going to list a bunch of equations here and we're going to solve them. I'm going to start with the one that we began the section with, just to show you how to do this. Well, what the addition property says is that I can do something to both sides. What I want to do is I want to take this letter, this variable, and I want to isolate it. I want it to be by itself. And I want you to write this down. I want to isolate the unknown. That's the phrase we're going to use, isolate the unknown. If I isolate the x in an equation, it'll just tell me what the x equals. It'll say x equals this, and I'll know what the letter is. So isolate the unknown is the official way of saying it. Get the x by itself is another way to talk about this. Now, how do you do that? Well, what you do is you have to take this minus 3 and move it somehow. The way we're going to do that is we're going to add 3, because whenever you have a number that's connected to a letter, if you use the opposite operation, you can zero it out or cancel it out. Because here negative 3 plus 3 is a 0, so I end up wiping those out. But the addition property of equality says whatever I do to one side, I have to also do to the other side. So if I add 3 over here, I have to also add 3 to the right-hand side. So in this case, x equals 5 plus 3 is 8, and my answer is x equals 8. This idea of doing something from on the left and on the right, it's like balancing a scale. You could imagine that the equal sign is like a scale, and whatever you do to the left side, you also have to do to the right side to keep the equation balanced. Let's do another example. You don't have to just have x, you can have other letters. M minus 48 equals 29. Let's try this one. I want to isolate the m, or get the m by itself, and I do that by adding a 48, because subtraction of a 48 can be eliminated by adding 48. And whatever I do to the left side, I have to do to the right. Cross those out. So now it's just a matter of adding 29 and 48. 8 and 9 is 17. 4, 7, so m equals 77. And that's the solution to my equation.